Welcome to Pomodoro Joe for Saturday, February 11th, 2023. Today we're looking at LeetCode problem 1129, shortest path with alternating colors. It's a medium problem. And the problem statement says, you are given an integer n, the number of nodes in a directed graph, where the nodes are labeled from 0 to n minus 1. Each edge is red or blue in the graph, and there could be self-edges and parallel edges. You are given two arrays, red edges and blue edges, where red edges at index I is equal to AB. That indicates that there is a directed red edge from node A to node B. And then similarly, you have blue edges J, which indicates there's a directed edge between. Okay, gotcha. So we are to return an array answers of length n, where each answer x is the length of the shortest path from node 0 to node x, such that the edge colors alternate along the path, or -1 if the path does not exist. Okay, let's unpack that a little bit. Essentially, you have a directed graph with n nodes in it. There are edges between the nodes, but the edges have colors, red and blue. You need to find the shortest path from node 0 to every single node in your graph, but the path has to have alternating colored edges, red and blue. Okay, so with that, we will put 25 minutes on the Pomodoro timer and get started. As usual, I will start with a result. And in this case, it will be a list with -1 as the default value, and it will be of length n. And at the end, we'll return our result. Okay, so I think the first step that I'll take is I'll break these edges out into something a little bit more useful. So what I really want is to be able to say from a given node, what are all the connected nodes along a red edge or a blue edge? So I think I'll convert this into a dictionary, where the key is going to be the node that I'm at, and the value will be all of the connected nodes along a red or blue edge. So I think I'll need actually two separate dictionaries. One will be called red. We'll have red links. I'll make it a default dictionary of set. And we'll need one for blue, so we'll have blue links. So I'm using set here because it should be a little bit faster than a list, and essentially the key will be the node that I'm at, and the value will be the set of all the nodes that I can reach along either a red or blue edge. Now we need to populate these. So okay, so for every edge in our red edges, we'll have a new entry in our red links for edge 0, edge at index 0, and we'll add edge index 1 because that is the connected node. Okay, that's pretty straightforward, and we'll do the same for blue. All right, now we have these in a little bit more usable forms. I'll also create, this isn't strictly necessary, but it helps me visualize this a little bit better. This is an equivalent to, say, an enum in other languages, but I'll have red and blue. Just a way to distinguish the two colors. All right, now the next step is to figure out a plan. I think the plan here is to do a graph traversal. In our case, I think the best way to do this would be a breadth-first search. So I'll start at node 0, and because I know what they're looking for is the distance between node 0 and all the other nodes, I can start at node 0 and just traverse the graph in all directions until I reach every single node I can reach. So for that, I'll create a queue, and it will just be a list. Now, what will we put in this list? Well, not really sure yet. So for now, I'll just say it's the node. So in our case, we'll start at node 0. And then we'll also have to keep track of which nodes we've visited so we don't end up in cycles. So I'll have a visited set. Okay, so now thinking about this, I'll basically say, while I have some nodes still in the queue, I'll keep traversing. And we'll grab that node and we'll say queue. And we'll pop 0 because we want to do a breadth first search. If you did pop -1, that would be a depth first search, but we want to go wide. Okay, so we'll grab the node, and then from here, we'll see where we can go. I already spotted a problem with my approach. I not only need to know the node that I'm at, I need to know what colored edges are available to me. Like, where can I go from here? So I don't just need the node, I also need the next color that I can go through. So for here, I'll make this node 0. And since we're at node 0, we can go to blue or red. So we can go to blue, and then I'll also have a node 0, and it can go to red. Okay, now once I reach my destination node, I can see another issue. I need to know how many nodes I've been through, or how many edges I've traversed to get to my current node. So I'll also need to keep my, I guess, path length. And since we're starting at node 0, currently the path length is 0. I think that's all I'm going to need. Okay, so I'm going to grab the node, and in this case, it's not just the node anymore. It's the node, it's the next color, and it's the path length. Okay, now we do our check. Are we at a node that we haven't seen before, or are we at a node that we might have visited but had a longer path? Is this path shorter? So let's just check if our result at this node is equal to -1. That means we haven't been to this node before. So we can definitely replace that -1 with this path length. Or is this result at the node greater than our current path length? We can also replace the path length. So now our result for this node is going to be our path length. Okay, that gives us our result. Next, we need to check out where we can go from here. We also want to make sure that we update our visited so that we don't end up going in cycles. So visited, add, and we can't just add the node, again, because we have not just the node, but the colored edge we're allowed to take. So we need to add the node and the colored edge. So I'll package that up again in a tuple. Now I'm not packaging up the path length because the path length may vary. We might come back to this node and have a shorter path length, for example. So let's not package the path length along here, along with the node and the next color. Okay, now we have to see where can we go from this node. We've visited this node. We might not be done yet. We might want to go through the rest of the graph. So how do we know where we can go? Well, it kind of has to do with this next color. So this next color is telling us which edges we're allowed to take. So let's see, if the next color is equal to red, well then we can take all of the edges from this node that are red edges. And that's conveniently stored in our red links list up here. So for every node, for every next node in our red links, because these are the next color we're allowed to take, we'll check to see first, did we visit this node already? So let's see if, and that's going to be the next node, and the color will be blue in this case. So this is where it gets a little tricky. We're going to this next node, but the next node, its next color will be blue. So we have to make sure that the next node's blue is not in our visited. Or I can say if it isn't visited, we'll continue. I think I like that better. So if the next node blue is already in our visited, we'll just continue. Otherwise, we can add this next node to our queue and go visit that node. So we'll append, and in this case, we not only need the next node and the color, so next node blue, we also need to add one to our current path length. So we'll say next node. And our path length plus 1. So this takes care of if we came in and we are on a blue edge and we're allowed to take a red edge out, or in the 0 node case, we didn't come in on any edge. We're just allowed to take red nodes or red edges out. I'll have to do the same thing for all the blue edges. So let's see, we'll replace red with blue and blue with red. Okay, I think that should do it. I probably have a ton of typos, but we'll check it out. Oh, and we have a failure, so we missed something in here. What did we miss? We need to specify which node we're coming from. Let's see how we do. All right, we pass. And we beat 57% for runtime and 73% for memory. So, not too bad. All right, I think I better stop while I'm ahead. We passed with 57%, better than half. I'll take it. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.